afternoon, everyone, and thank you for joining us here this afternoon. I'm Lauren Rublin, Senior Managing Editor of Barron's Magazine, a financial and investment magazine in New York published by Dow Jones, and we've been covering investments, markets, and change for 98 years. So I am very excited to be here today. It's my first visit to China, and I hope it won't be my last. Let's get down to business. The industrial Internet of Things is coming, whether we're ready or not, and it will revolutionize the landscape for business. Its applications will be manifest in nearly every industry, from manufacturing and retailing to energy and transportation. And its benefits will include gains in quality, efficiency, productivity, energy, cost savings, and many more. The question, however, is how to unlock and accelerate this brave new world, especially when many parts of an enterprise and many enterprises don't speak the same technical language. In other words, there are significant barriers to sharing critical data between and among companies and industries, and even among different countries. So we have an issue of standardizing data. Fortunately, I'm sharing the stage today with 4 people who are experts in this area and can walk us through how to unlock the industrial Internet of Things. Dr. Jay Lee is Vice Chairman of Foxconn Industrial Internet and a distinguished professor at the University of Cincinnati. Dr. Jun Ni is a professor of manufacturing science and honorary dean of the University of Michigan and the Shanghai Jiaotong University Joint Institute. Bhairavi Jani is executive director of SEA Group of Companies. And Deepak Krishnamurthy is executive vice president and chief strategy officer of SAP. So let's get down to business. Let's start first with why the industrial Internet of Things is going to be such a game changer. Would you like to start, Dr. Lee?
Yeah. Well, if we look at how Internet changed our life, which they did, and because people like to be more connected with opportunities to network other resources. So, but the industrial Internet will change the industry. Why? Because the industry has many pains. Those pains are not individually solvable, because you have to connect to the other resources. For example, when you have asset, you need to predict the issue. The expert may not be in your control, under your control. Your supplier have to be connected to the right problems. The who control that opportunities really, who can discover those pains first, right? Who define those pains. So Internet change our life, but industrial Internet will change our industry. So that's where we come from the pain. Then we start creating a profit. Why? When you save more, when you generate more revenues and more value for customers, more profits. Eventually, you create partnerships that can collaborate. Finally, you need a platform to sustain that industry, the ecosystem. Yeah.
What will be the manifestation of this for the end user?
The end user, I guess, if you look at the whole ecosystem point of view, industry where is the integrated resource from suppliers, manufacturers, and customers. The end users could be either manufacturer or could be a product receiver. Product receiver will be consumer side, and the manufacturer will be to use that resource to produce product for consumers. So I think the one thing to do is how we create a shared economy for that, right? Because when you have the shared value, that consumers can customize the product they want in different location, different time scale. And the manufacturers can integrate the resource from different level of dimensionality. Yeah.
Thank you. Dr. Ni, where would you say we are in the current state of things with industrial IoT?
Well, I do agree with Professor Jay Lee's comment. If you look at our social media, social life, or even consumer society, the Internet has changed life in the last 20 years. And people expect the industrial Internet of Things, or IIoT, will have a similar impact to industry. In terms of where we are, of course, from those scholars, academic people already mapped out the roadmap for how IoT will transform industry in terms of solving their KPIs. Also, media already declared we are here already. We are at the age of IoT, and also government has encouraged, particularly in China, in some of the developed countries, encourage business to adapt to this new technology. But in reality, I think from the business point of view, it's really only the beginning. Because many of the issues you mentioned in your opening, such as standardization, interoperability of data from different sources, different equipment supply, and also the data sharing, data security, and data sovereignty, the privacy issue, the competitiveness of industrial internet. Because IoT is very different than a consumer social internet. For the social internet, there's a natural tendency for people to share as much as possible. For example, as a consumer, if you want to buy any particular goods, you would like to basically search all possible vendors in the world. Same thing, if I'm a vendor, I like to see all consumers around the world to see my information. There's a natural tendency for sharing. But if you look at industrial IoT, there's a natural barrier preventing data from sharing, preventing data from leaving our factory wall. Even, for example, you are a robotic user, the moment you buy a FANUC or KUKA robot in your factory, the data does not belong to KUKA or does not belong to FANUC. I don't want that's my trade secret, that's my competitive advantage. So those are natural barriers. So I think, answer your question, we are in the beginning. There's many issues to be addressed.
Let me ask, which industries do you think will be first at unlocking data and at developing the full industrial Internet of Things?
Well, from my personal experience, I work closely with automotive industry from where I come from Michigan. There's a lot already. People, not only the OEMs, but the tier one suppliers already utilize the industrial internet. They basically share the information with the customer, the OEMs, the vehicle design, all the toolings, all the necessary changes already been shared. But also for the OEM, they find ways. For example, I know one of the major automotive maker. On one hand, they don't want the data to leave the factory, but on the other hand, they trust a third party to secure the data. They set up an external server so the data can be shared with a controlled environment.
Deepak, let me ask you, how do you think across industries people can develop trust to share data?
Lauren, before I go there, right, I just want to go back to your earlier question. I think you asked a very important question in terms of where's the value going to get created. The value where industrial IoT is going to create is going to be around having a common communication layer. So in the history, if you look at the last, I don't know, like 10,000 years, 20,000 years, civilization has always jumped, and there's a common language. So when you have a common language, common communication models, that's when productivity increases happen. That's why civilization improves. That's the big idea with industrial IoT, is that you have a common language, a common communication model, and then you can have interoperability, and then people share information, and there's a lot more productivity. So that's kind of where we are now in terms of the language itself. I think we are in early stages of defining that language. We're probably in the spoken language. Nothing's been written so far. So think of that as the place where we are in terms of the opportunity. And the opportunity is trillions, depending on whichever study that you talk to, it's 13 trillion or 20 trillion. Think about it from a end customer perspective. It's about getting 5-10 percentage points in operating margin improvements, and that's the opportunity, right? So, and that's the promise. I think we are at very, very early stages in terms of capturing that opportunity, and now we probably if you have more interoperability and data sharing, and going back to your question, which is how do companies share data? I think it's a very tricky question. You have a couple of headwinds that first impact you. One is the whole notion of to what Professor Jun said was around what's the data ownership. It's a source of competitive advantage for me. I don't want to share it with my competitor or my supply chain partner. So how do you manage that particular dilemma? The second challenge most companies face is in international supply chains, how do you manage data across borders? So those are two big challenges that companies and industries face. And there are answers to both, the solutions to both. One is that creating an open industry alliance that has interoperability standards, that has some basic minimum information that can be shared, that doesn't have to be competitive, that helps the end consumer. So what SAP is doing, for instance, is creating an open alliance 4.0. KUKA and SAP and a few other manufacturers are part of it, where it's all about sharing data openly so that you have common information about maintenance record, IoT information, all that can be shared with the end customer. So that's one way of creating these alliances or industry consortiums that can solve vertical by vertical or industry by industry. The second challenge is a little bit more tricky in terms of cross-border data sharing. And that is where things like edge computing, which is where you don't take the data and move it to the cloud, but you have the data and data processing at the edge where the machine is or where the transportation medium is. And you keep the data there and then you process it over there. And then you don't necessarily have to worry about cross-border data sharing. So those are solutions that are evolving, and those should hopefully solve the data sharing and the cross-border data issue.
Thank you. Bhairavi, excuse me. You are at a logistics company, so how does the issue look from that perspective?
Well, I think, as Deepak very rightly pointed out, and what we heard, so the nature of society and social fabric is becoming more and more social, more and more hyper-local, and therefore you're not anymore manufacturing one phone in one country or in one factory. You're really manufacturing one product in maybe 20 different places. So the nature of where a product is manufactured, and therefore the very process of manufacturing is shifted. It's a whole lot about the supply chain between different parts and phases of manufacturing than just looking at supply chain separately. And therefore, supply chain then becomes a bridge through which the data is shared. So from that perspective, there is a lot more role for logistics and supply chain processes and companies to play in being the messengers of information sharing till we really come up with more common platforms. The second piece of information here is that now as people buy more around the world from different places through e-commerce and many other new evolved models, a small manufacturer can actually sell in a very far-off country, and that's changing the way how things are moving. So when you talk about the word industrial internet of things, it's not just about manufacturing, but it is largely about this entire process of from where is the demand, the consumption, to how does it move backward into really manufacturing at multiple places and a product coming out of it at the end of the process. So I think that's the new shift that you're looking for. In a way, I mean, if I were to relate it to, you mentioned history, Deepak, is a point where what happened with the printing press and Gutenberg, right? So here comes Johannes Gutenberg and changes a certain way in terms of the molds that happen in printing, and 100 years later, and there are printing presses all around Europe. And I really think that's where we are in terms of the industrial Internet of Things, in general, the Internet of Things, that we are at that Gutenberg moment, and we're going to get something that's going to allow us to share data more openly and in a more trustful and safe environment, and that's going to really make a significant shift.
We need to share data. We've established that. So who is going to be in charge of setting standards for sharing data in industries, across countries? What kind of a framework should be established?
Well, I think in general, you have to look at who are leading that transformation, right? It could be led by a major customer for auto industry, the car maker can drive that, or a product maker can drive that. But also can be led by manufacturers. For example, in Foxconn Industrial Internet, we drive the whole transformation based on the massive resources we have. For example, we own 175,000 machine tools. 175,000 machine tools mean a lot of stuff. We have different types of suppliers. And so when we own those data in the manufacturing world, We can predict machinery from spindle, bearing, cutting tools, processes, lubricants, you name it. So machine maker, actually, they like to work with us because they need those things to improve their performance. Our suppliers also need those things from us because they can have a rapid and more responsive demand forecasting about what we need. So that's from a manufacturing point of view, right? But from the product design point of view, you can drive as well, depending on who are driving that. But I think it really comes down to, if I use one sentence to describe what the industrial internet is, it's from data to decision. D to D. Data from all sources, all areas. You want to make decision. So the two approach, I connect to all the things I need so I can make decision faster. And then to connect things, you have to have standard, you need some standard format. This machine, that machine made by different vendors. I want to have same data format. Okay, and you standardize edge devices, right?
How do you bring smaller manufacturers into this kind of framework?
That's very critical because in the end, suppliers come down to their own small companies in general. So small companies, which they have a much faster development cycle, much faster idea and innovation. So if you can identify those gaps, which are not defined earlier in our product manufacturing environment, small company can react much faster. So to me, IIoT is not just to solve those, define the problems, they're also to discover those undefined opportunities. So we can nurture, we can foster fast innovation for small companies. So for example, data foundry, we have developed called data foundry. Data foundry means we have a different set of data we generate. We bring a small company come in, that could be AI company, could be industrial big data company. They can quickly solve the problem. Immediately we can invest the company. I don't need to try and error. You can solve it, I invest in it right away. Faster. Yeah.
Can I jump on to the discussion on the small business?
Yes.
I think when we talk about the industrial Internet of Things, the large corporations that have the financial and the human talent, they can pursue on their own, at their own strategy and their own pace. But the smaller, we call SMEs, they are actually left behind because they lack of financial and the human talent. I think this is where the whole society, sometimes the associations, they have to collectively educate small business and reduce the risk for them to jump into this bandwagon. Because for them, they cannot afford to make too many failed investment. And once is too many. So in that case, we need to really think about how do we improve the talent. The IoT is not just in connect your equipment to internet. It's ability to discover the value behind the data, like Professor Lee said, from D to D, data to decision. That requires a lot of analytic skill, human talent. That's where the small business is lacking.
Speaking of talent, we have two professors here. How do you nurture that kind of talent at the university level? How do you build the skills? And do you see that there are sufficient skills or a skills gap?
Yeah, well, certainly you need different types of approach from the industry side, from university side, from the association, industry sector side. They're quite different. From university side, we teach more. In general, I call 4P based, right? The first called principle based. I teach the principle. What is the data analytics? What is the feature extraction? What is the conversion? The second thing, practice based. If I give a set of data to you, do you know how to handle it? The third is project based. You go home, formulate your own projects. The fourth one is called professional based. You help everyone solve the problems. So 4P level, I think university based is more principle based. I give you a principle, I give you a tool, I give you the basic foundation. But industry need to focus on practices and project formulation skills. And the association can focus on professional. I give you a certificate. How do you certify the skills? In what way? You certify in this country, well, that certification can meet this country. The labor is going to be globally talent integrated. So we need a three different type of approach, right? So in industry, so we have a systematic approach to train our worker engineers in different level. First one principle, practices, project, then we're going to train mass black belt of industrial AI, industrial IoT. So each individual, when they graduate, they can train another 20 of each. I can have a highly scalable workforce development. Yeah, so I think last year we start from about less than 100 experts. This year we have exceeded over 1,000.
And growing, I'm sure.
Yes, very fast.
One entity we haven't discussed yet is government and what role regulators and government will play in developing the industrial IoT. Deepak, I wonder if you can share your thoughts on that.
Sure. Germany, where SAP is based, is probably one of the more advanced nations where governments are taking a very proactive stance in terms of how Industry 4.0 is going to be built out. So there is, German government in partnership with the industry created this consortium called Platform Industry 4.0, which is a consortium of companies, the big manufacturers, you take Siemens and Bosch, and the big industrial companies like if you take Daimler, BMW, Volkswagen, and then you have software companies like SAP, and not just German companies, but also international companies like Microsoft, all part of the consortium. They're all part of the consortium where everybody is coming together to go and create standards for interoperability. Now, I think it goes back to your earlier question, how do you actually get to these interoperability standards, is to making sure that the regulatory environment, the data sharing environment, and the interoperability is being done in a way where it's aligned with where the industry is and where the technology is. Oftentimes, regulation is a few years, if not a few decades, behind where the technology is. So it's the opportunity is to go create the regulations in lockstep with what's happening, not just where the technology is today, but where technology is going to be in the future. So for example, it's not just about where data privacy and data regulation between cross-border, the issue that I referred to earlier, but in terms of, okay, if machines are making decisions, what's the data rationale behind it? Is there any data bias in terms of how a machine makes a decision? So understanding what the future is going to be, understanding what kind of ethics that you need to build into predictive intelligence that's going to drive these machines to take autonomous decisions is going to be important to be defined by the going forward regulation. So I think it's an area where governments need to play a role because this has far-reaching impact on the society. It has far-reaching impact on the jobs. So clearly there's a huge talent gap in terms of the new industrial IoT jobs, but then it's not easy to retrain and cross-train people in terms of people operating CNC controllers going from there to being data scientists and being people who can go create predictive algorithms, not easy. So that requires, again, governments to play a very active role in creating training programs, reskilling programs, providing incentives for large corporations to retrain their workforce. So those are areas where governments can play a very proactive role.
Where does this leave labor? I think I will ask that to Bhairavi. Many people are afraid that this kind of development that we're talking about is going to leave labor out in the cold, that people will lose jobs, this will cause social issues. What is your perspective on that?
So, I mean, I want to take a cue from what Deepak said. I would first say that government needs to do its own capacity building, right, about this. Within the government, there isn't really complete understanding of this entire new dynamic of what an industrial IoT is going to do, what data is going to do. The new trade negotiations are going to be about where data resides and whose data it is, right? In terms of whether it's e-commerce consumers or even, patenting manufacturing. And I think, therefore, there needs to be some work done by industry bodies and academia to really capacity build government itself so that regulation is not playing a very high catch-up game. And if you do that, then you're also not just uplifting the knowledge base that's inside the government administration, but also equipping the politician, who's the public leader, to really start understanding this piece better. Because, if you really look at the people who come under pressure from society about these questions are actual politicians who have to answer the questions about, job losses and how are we going to do this, and are you inviting new technologies in that's going to create job shifts for people. So again, going back to the Gutenberg example, there must be a whole lot of people who only wrote and translated Latin before the printing presses took off, and they must have been threatened out of job. And there must have been a way that got handled. So what I would really like to say to a whole lot of people is that humanity has done this before, time and again. So it's not the first time. It's just a new form of communication, a new form, a new leap that we're taking. And today we have far more tools, we're far more connected to be able to do that faster and with less costs than we did earlier. So I would say that media plays a very, very big role in really making examples of IoT to be more real and approachable than an abstract statement out there. Academia, schools, I think play a very important role. I would not even wait till university. I think schools play a very, very important role to get children to start getting exposed to a new kind of skill set that may be required in terms of building it up by the time they come into workforce or start thinking about skills or academia as the next career place. And I think the biggest burden of this is on companies that are already leading and have tried sandbox models and solutions that have worked. We have some of them here on the dais today to really share their experiences with as many people as possible, both success and failure.
I'm curious, we are at the beginning in the infancy, as all of you say. How long is this going to take to build out a full industrial Internet of Things? Are we talking years? Are we talking decades? Dr. Nee, what do you think?
Well, my projection here will be years, not decades. It's very much faster because we learn from the internet. Many of the technology there, actually the regulatory barrier is one we need to crack. For example, we talk about the data across different borders. For a certain country like European Union, there's different data privacy. In North America, the data can be free flow. But in China, maybe the data cannot leave the country. So for global corporations, where do you set up your server? Where do you reside the data, hold the data? I think that's become a challenge. That's regulatory. But technology-wide, actually they are here. You can, nowadays, a smart sensor, the edge computing, all the cloud-based or frog-based computing become readily available. It's really the security issue, the regulatory issue, and talent issue are the barrier, in my opinion.
What about cost? How much is all of this going to cost?
Well, in general, I would say, right, is the whole thing, the question you asked earlier, right, it's really about how each company or each enterprise wants to transform. So the scale of a transformation takes time, but the speed of transformation also is very fast if you want to do a low-hanging fruits, right? For example, if I take a company, if you want to improve yourself to a perfect lean, perfect agile, perfect predictive system, then you should try to connect all the things you know to discover something you don't know, like you go to physical exam to find out something you don't know. Okay, now I can know how to improve myself. But if you just keep watching what you know, you're going to still have evils out there. So to me, the reason IoT can change the traditional lean, because we connect to the data from different sources of opportunity. Could be sensor, controller, could be different type of product, networks. So I can try to do a correlation, comparison, eventually find out opportunity and gaps. So the scale means how fast. So if I can do one, if I save X money, 10%, if I spend 10,000, I save a lot of money. From the money I saved, I invest in talents and more scalable resources, right? So it's like a continuous spiral type of growth.
So it seems like you're saying that regardless of the cost in some ways, the benefits will far outweigh the costs.
You need to have a quick success. Sure, I would say the early success to provide the confidence, not just to you, to your shareholders, your own employees, and also your customers. You can do it. Then eventually you can influence your suppliers. You can influence your customers. You are the winner, right? So it's contagious. That is important.
Let me also add to the cost discussion. I think you have to look at the business from different groups. For the large multinational corporations, usually in their factory already, their infrastructure in place. They have all the equipment, the data available from either control or from PLC, it's there. It's just a matter of how to utilize the data, how to utilize the information generated from the data to optimize, to improve their business. For the small, medium enterprises, I think the challenge is many of the smaller ones, in particular micro business, they are in the bottom of the supply network, and they lack of the infrastructure and maybe lack of talent. But technology, for example, the 5G, when the 5G for mobile system come, maybe they can leapfrog, and the cost will be low. Instead of re-establish the fiber, the internet in the factory, they can directly hook up to really, there's a lot of smart sensor already. It's very inexpensive. You attach the equipment and send the data to a server through the platform, through a public server. Then the cost can be leveraged. So I don't believe cost will be an issue if you can justify the return on your investment, the business purpose.
So shareholders will pay for this.
Exactly.
Yeah, I think the cost, the way to look at it is that companies need to make two levels of investment. A lot of companies are making investments in the technology, and the technology is in connecting the sensors, collecting the data into a cloud, and trying to go and try to make sense of data. At this point in time, there's probably a lot of information overload that's from the data that's been collected, and people are trying to still make sense of the investments that they have made, and they're trying to recalibrate what they should be doing. The value that's going to be created is from the data that's already been collected. So even today, even if you don't do interoperability, there's enormous value in getting data in the machines that you already own and trying to make sense from it and trying to do stuff like predictive maintenance. So there's already value that you can, going back to the earlier discussion, using those initial proof of concepts and pilots, getting some quick wins and using those quick wins to drive value would be a way forward. And shareholders would like that. But you get massive value only when you start collecting much more information and doing it at scale. But then the challenge is going to be, it's also almost an organizational competency. It goes back to a talent issue. So you need to have the discipline, the agility in the organization to go and change the processes. Going and doing the things the same way that you have done before isn't going to deliver value. So you got to think through every single part of your value chain, from the consumer all the way into the manufacturing, into your supply chain, and figure out how do you use data better. How do you redesign your processes, and then you can start really, really delivering value to your shareholders.
And I think also the way the supply chain is shifted and how the process of manufacturing or even servicing something is shifting so significantly that what you call a cost-benefit analysis is shifting. And so, determining the return on investment on something like this has different parameters and framework. And there are enough use cases out there, which are early use cases. The more they are kind of shared and more understanding of that is developed, that is better. But I think we have to understand very clearly that core competencies are shifting. And so who's playing the bigger role is also shifting in the entire value chain of manufacturing. And are companies really ready for that change? Are companies ready to collaborate with their competitors? Because that's the behavioral change that is kind of expected if we really want to see full benefits of the IoT that we're really envisioning in the next decade to take place.
Let's talk about some of the risks for a minute of industrial IoT. This tremendous amount of data is something that leaves industry open to hacking and other sorts of risks. I was at a panel the other day on cybersecurity when somebody mentioned that data is a vast open surface area where attackers can come in, and the sentence sort of stuck with me. So what kinds of risks can arise and how should they be managed? Dr. Ni, what is your view?
There's a several front. On the one end, security is an issue. And if you have a control, in particular for industrial internet, you want to send command or reference through the network. What if the network is intercepted by a hacker and we inject with the wrong command? That creates a disaster. Not just like your personal information is leaking out, but really it can cause a serious damage. That's on one side. Second part of the risk is on the human side. In the old day, in the traditional, conventional way of manufacturing or industrial operation, human is always in control. Now, what if you have AI start to take some autonomous action, and if it's hacked, And that could be another challenge. The human is out of the loop. I think those are the risks I can see from what we interact with many of the companies.
And as the data connects so many companies, then the effects of that would ripple forward across supply chains to customers and so forth.
That's right.
So what is the best way to protect against it, do you think?
Well, some of the companies start to create their own internal firewall. They will not let that, they still have this type of industrial IoT, but with a boundary carved out with that. They have an internal encryption and with a firewall and a strict data exchange. That's one way to enforce that. Another way is really for the mission critical system, you always have a double check or redundancy. To verify before you really execute the command. I think those are some of the technical approaches people can deploy to increase the security of the system.
Yeah, maybe I can add the footnote for this, right? In general, we have 3 levels of the security concern, right? One is the network security, one is the data security, the third one is very important, it's called cybersecurity, which is much more an integrated environment. So we normally use a 5C architecture, 5C. The first C is called connection. Where to connect? Bluetooth and Wi-Fi and the 5G, whatever. You select and sometimes fiber. So the different requirement for different business. Second, the conversion. In many asset side, operation side, people have said, well, why I don't need to transmit the data. I need to get feature out of it. So on the edge side, we could convert data to the edge. Could be go gateway, could be edge devices. But in FII, Foxconn Industrial Internet, we call FOC, connect to more machines. The third level is cybersecurity side, we focus on management of these relationship with data. Where data belong to, where should belong, because the 2 points connect mean relationship. So relationship is important. If you only have a data A, data B, you probably cannot do anything. But if I connect A to B, wow, I know something. So in cyber side, managing relationship, like your WeChat is managing your social relationships. So WeChat is your cyber life, Line is your cyber life, WhatsApp is your cyber life. The fourth level called cognition. Who's reviewing the data? You are my boss, you view the data. You're my customer, you view my data. So who else cannot view the data, right? The highest level I call configuration. Who can change the operation? You can see it, but you cannot change. So what can you do? So eventually, connection, conversion, cyber, cognition, and configuration. So each level, we add different level of security. That's why we use 5C, right? It's if you Google cyber physical system, Wikipedia, you'll find the 5C architecture. We put on the public domain. Yeah.
Okay, I have a broader question. We'll address this to Bhairavi. Do you see industrial IoT really fostering greater economic growth? What do you think it will mean in terms of global GDP?
Well, I think it's definitely changing in its early years, just with the way the trade practices are, changing and the trade negotiations are changing. So it definitely is changing the nature of global trade in itself. Apart from, of course, a few trade negotiations that happen on Twitter nowadays. But in all seriousness, I think what it's doing is it's making the process more visible to people who are getting affected by it than it was before. And I think that's a big shift. The second big shift is if you really look at demographics of the countries, countries with younger population, the ability and opportunity to skill more people for this change are at a natural advantage, right, than those with older population. So how will that balance work out? And if you really look at the GDP baskets of the world's developed countries, rich countries, the age balance is towards more developing nations, Asia, Africa. So how will that balance, the trade balance, is also another story. And I don't think it is an island by itself. It's very much inside about the kind of work that, for example, looking at women participation in workforce? And are there things that industrial AI can do that allows greater women participation on manufacturing shop floor? So it would also bring some really huge social capital that we haven't really started understanding because we haven't implemented it at that kind of scale. But I think in terms of reskilling, job adaptability, company agility, change behavior, more share of global trade, even by smaller players, just because they have the ability to understand tech, is really going to change the global balance in terms of trade and the way it is. And I think that's a huge opportunity. The risk there is that if there isn't enough trust, and therefore what I mean by that is that if there are security concerns, so for example, when we sit in the World Customs Organization to look at blockchain technology, data being shared between different customs of different countries, security and terrorism feature as a very big naysayer for how global collaboration on customs can happen. And if there is better collaboration, the dwell time of the goods go down, there's efficiency in supply chain, higher return of investment for the same technology that you're deploying. But it is not achieving its target because there is mistrust between nations about security and terrorism, and therefore it does call for a certain level of leadership that needs to take place, which is beyond technology. It's like, what are we going to do to meet this new challenge? It is no different than climate change. It is no different than the nature of work that's changing. It, in a way, is a challenge by itself.
I actually see this as a huge economic value creator from a GDP perspective over the next 5 years, 10 years. So clearly, industrial IoT is going to unlock new opportunities for manufacturers to go and reach out to new consumer segments at much lower price points. And so that's going to go create a lot more economic value. It's going to open up new markets and open up new ways to go and drive value for both the manufacturers and their supply chain partners. I think that's going to happen. It's also going to create new business models. So we are more and more moving from a building just product and selling the product to much more of a product as a service model. So as a service model, as they evolve, there's going to be a lot more value creation. So that's also going to drive some GDP growth. I think the third, which is probably underrated part of it, is the impact it's going to have on sustainability and energy efficiency. So pretty much every industrial IoT application or device is going to be much more energy efficient because you're going to optimize it for peak, you're going to optimize it for underutilization. So you're going to use the data and be much more energy efficient in your supply chain operations, in your manufacturing operations. And if that can reduce from a net carbon impact perspective reduce it by 20% or 30%, it's going to have economic value as well. That's not currently calculated by GDP, right? So overall, it's definitely going to, and over time, hopefully it's going to create jobs and then add more value from that perspective and drive the consumer consumption. So there's a lot of positives to look forward to. At the same time, again, you need to think through the labor impact, the jobs impact, the social impact that we discussed earlier.
Well, if I can add some additional comments, I think the traditional way we define GDP, whatever it's called, how you produce, how much you produce, really based on the visible definition, how you define. But I think once you know how to integrate the IoT to those valuable things, you change 3 things, right? First, you make things faster. Why faster? Because I can connect things, I can control those things traditionally we couldn't do before. Data to decision. The second thing, we were able to do a more flexible. Why? Because I can remotely managing things. I can use my smartphone to managing things, which we couldn't do before. The third things we can do based on the facts. Traditional work based on experience. Now we're based on evidence. Experience cannot give to the next generation. Very difficult. Evidence can, yes. So that will have a sustainability issue. So first, you have a faster, you can create a speed. Second, flexible, you give a scale. The third, you have a fact, you give to sustainable facts. So that would define the traditional GDP format, actually. Not mention the value you created. For example, right now we're talking. You record a video. It doesn't share to people watching. That's only just a fraction of people can do it. You convert our voice to text. The text convert to different languages. Everyone have an app, can see it. Then for $1 you sell. Then tonight you can make million, right?
I think that's a great idea. So I think we've used the word will a lot on this panel and will in general at this meeting. So let's talk about is for 1 minute before we go to audience questions. And give me an example of a good industry collaboration that is existing right now. And maybe we can go down the row and each person can give me an example of something currently in force.
Well, I can start here.
Sure.
I think that we currently work with the World Economic Forum. We are one of the lighthouse site. As you all know, lighthouse site means the one of a good example. I want to say, well, you couldn't say best example, but at least a good example to show how an industry has transformed themselves from traditional practices to a very leading edge kind of a performance. So we have to integrate our physical operation across different type of sectors. We have different type of business. Plus, we have the vertical integrate our suppliers and to our customers, right? So to me, the lighthouse site is a good example. We have to demonstrate, and we'll have to share. We also have invited different people in the industry. They can see what we do, and we benchmark with the different type of businesses, right? So eventually, then we also educate. So we are now bringing people internally and externally to train people. So this is a typical, I will say, the mission of the lighthouse, right? To use your success or lesson learned to continue change the ecosystem, and finally you can educate more workforce, more skills. Yeah.
Let me give you an example. It's a real example. It's a collaboration between automotive OEM, the equipment supplier, and the IT provider. In General Motors, I work with FANUC, with Cisco. FANUC sell robotics. When they sell the robot, they like to get the data from the robot. However, the moment you install your robot into an automotive plant, that equipment is no longer yours. It belongs to the end user. They have no access to the data. And General Motors also didn't want any of the data to leave factory wall. How do they solve the problem? Cisco jumped in as a world reputable secure networks provider. They create a third-party independent warehouse. So the data, only the robotic data, not the processing data, not production data, only the robotic data can be transferred to that particular secure site. And through their analysis, they can improve, they can predict the downtime of a robot. Because in automotive application, every minute downtime, it's $20,000 cost in US market. So by creating this three-party collaborative effort that saved General Motors millions of dollars and also create real data from equipment manufacturer, FANUC, they see how their robot being used in automotive production. And Cisco, on the other hand, they create a secure network for this. So that's a really vivid example. It's happening in North America. All General Motors plants worldwide are deploying this particular collaborative effort. That's good IIoT application.
That's excellent. Can you think of anything that is actually working now in terms of an industry collaboration?
Well, I think if there are two examples. Mm-hmm. One example is of three customers which are in consumer space that we're seeing using IoT as tool to really get live dynamic customer data back into their supply chain and actually making a demand-based supply chain happen on a far more agile basis, far more dynamic basis, instead of it being from a supply to consumer side. Whether it's apparel, it's automotive, or consumer durables, all three companies are doing amazing work in doing that. There is now technology being used by a few startups that are applying that for smallholding farmers to take their produce to markets and using IoT to really connect those pieces of supply chain. So, like Deepak said, there are huge social capital and economic benefits as this technology becomes far more widely used.
I'm actually going to use an example from a slightly different industry to show how these things work. So SAP, Microsoft, and Adobe, we started a consortium called Open Data Information Exchange. in the consumer data space. So we have, well, it's more customer CRM data. So when you have customer data locked up in different systems, there's a way to exchange information, especially if a customer is using 3 different SAP or Microsoft or Adobe applications. Then that's starting to get a lot of traction, and we're seeing more and more companies coming and being part of the consortium. So there's an opportunity again for companies that possibly that are like competing with each other or somewhat in some kind of cooperation to work together and using a common understanding of if you can solve a joint customer value proposition, if you can solve a problem for the customer and then come together in a unique way, then I think people are willing to share data.
Thank you. Let's see if the audience has questions. I've certainly had a lot today.
Yeah.
We have one right down here. We'll get you the...
Hello, my name is Fang. I'm from China Finance Online. My question is for Dr. Li. So less than a month ago, the Chinese government issued a commercial license for 5G, and also the whole stadium is 5G covered. So 5G is already here. Can you tell us what role does 5G play with industrial IoT? Thanks.
5G is a new way of different type of transmission and also communication. So therefore, industry going to drive that. Of course, commercially, socially, yet there's some window. I believe 5G and industry has a better opportunities. For example, in the world of manufacturing, we believe 5G has a great opportunities, right? Because look at the sensor speed, the data rates, the time delay requirements can give us a greater insights about what's happening in our manufacturing processes. Traditionally, human being, we have a problem understanding the issue. Now we can deeper into the insight, right? Why thing happened. Used to be with a high-speed camera to capture all the things. 5G is like data level of a high-speed camera to understand what's going on based on time, delay, relationship. So we use it at such a way so we can help the performance of a manufacturing quality. Finally, you can help the customer services as well. So to me, in industrial application going to drive the 5G. Manufacturing in particular will have a good opportunity.
Can I also add to the question, answer to that question? If you think about Chinese families, before every family has a landline telephone, everybody jumped into mobile. Really leapfrog, they skipped the one generation of technology. But for a 5G for small business, it's just like a mobile phone did for Chinese families. Because large company had the infrastructure, factory information system, but small company, they don't. But now 5G provide opportunity because low cost, they can easily have the equipment connected to Internet of Things. And leapfrog, without install the fiber-based factory information system, they can directly from mobile to mobile and create that for them to instantly have the smart manufacturing capability.
And 5G is fundamentally a lot more reliable than a Wi-Fi network that you have. So especially in a mission-critical system, in a plant operations, you need to have that reliability so that you're not missing anything. So it adds a industry scale reliability. It's a low latency environment for you to make real-time decisions. And then finally, it's also like, from a power consumption perspective, sensors consume less power in a 5G environment.
Do we have other questions?
Yeah, there.
One over there. Thank you.
Hi, my name is Mariana. I'm from Brazil. I'd like to make a follow-up question on the collaboration issue. Is there any collaboration, or could you foresee any collaboration on issues of environment and human capital? I believe that within so much technology, we could bring more efficiency to manufacturing, to industrial processes, but also what are the works that we're not seeing today, and that maybe through collaboration we could prepare to skill the new workforce. Thank you.
Well, can we add some? Yeah, I think in general, right, collaboration always there, depends on how you define them. And sometimes collaboration based on problem-driven. I have a problem, yes, let's collaborate, solve the problem. Or you have opportunity-driven. For example, we discover the things that, right, that the customer or even supplier don't even notice that, right? So we help our suppliers to improve the performance. Now, we also bring in small companies And for example, we work with many companies. So when you find those gaps, right? So they say, oh, that's good. So we're going to define early innovation. So I think the collaboration have to be based on the value-driven. Value, I mean, could be a problem, it could be opportunities, growth. So to me, that can change the way how the content works, right? So we found this collaboration always work well when you have a shared value. Yeah.
So I think you're asking in terms of building capacity, and I think the biggest collaboration opportunity that we're not really seeing is for companies and cross-sectoral players to come together to capacity build everyone, right? That is the biggest opportunity in this. You know, I can give an example from way back in 90s when India started training engineers into coding skills to have them join IT companies, and multi-stakeholder people came together really to train large batch of youngsters into how to code. And without that, 20 years of that growth in that industry in India would not have been possible, for example. And I think there are many such opportunities that we can really look at. So there is, of course, the industrial IoT inside the organization, but then the ecosystem that surrounds it, whether it's suppliers, consumers, the society, the educational infrastructure around it, has a huge propensity to really completely transform. And that's where major collaboration is definitely possible.
Can I also add to that? I think it's a good question, talk about collaboration in the human capital development. Early in the discussion, we talked about the shortage of talents for this IoT domain. And because the IoT is very different than internet. Internet, a lot of talent are computer scientists, maybe mathematician, or statistician. But for IoT, the kind of talent, they need to have both the engineering domain knowledge, the business practice, the business process, as well as data analytics and IT. So in our educational institution, we collaborate with many companies. We not only train them in the technical domain, but we use a project base. The company sponsor project for them to really work, use a hands-on practical problem to integrate the skill from the engineering domain and with analytics. I think that's where the collaboration can help grow next generation of talents, which is needed today for this IoT.
That's actually a great point to build upon that point. It's almost like going back to the vocational skills and almost like an apprentice model where companies work with universities and you're starting to go and to get specialized resources at an early stage where you're not necessarily looking for generalists, you're looking for very specialized skills. And companies are working at the university level so that you're starting to have working students who are part of the internship program who work maybe 4 hours like a day or 2 hours a day to go build those skills. And that's probably a way forward to build the talent and drive better collaboration.
If I can make just one more to address it, because we use called the ABCDE model. A is AI, B is big data, C is cloud. D is domain knowledge where we can contribute. Then E called evidence. So when we have a talent development, the A guys, algorithm, B guys, big data, C guys, cloud providers, right? And D guy, domain provider, and E guys, evidence, that can become a knowledgeable workers, right? So we call ABCDE will create new workforce. Yeah.
Okay, we have less than 2 minutes left, so let's go down the row in reverse order. Closing thoughts. Deepak, why don't you start us?
Industrial Internet of Things is probably at a stage where there's probably more hype than reality, but there's enough substance in it, there's enough enough things going on. If you do the right things, if you collaborate and if we seek common ground as an industry with a cross-stakeholder kind of a mindset, then we should be able to unlock a ton of value.
Thank you.
I think where industrial IoT is, it needs to, it's in infancy, so we need to really look at how easily it can be made to understand by people who don't understand it. We need to make it accessible and applicable to as many sectors as possible. We need to make sure it is socializable in the sense that people can learn from each other and collaborate in it, and it needs to be done in a very timely manner so that society is prepared for the transformation that's headed its way.
IoT, actually, if you look at from the venture VC capital. This is the next new wave of investment all coming to IoT-related startups. So for the company, you have to be prepared. You have to do it. It's here to stay.
Yeah, also IIoT is the capability building process. It's not a one time, it's not a panacea, it's continuous improvements. You start from the low-hanging fruit side to prove the evidence, the confidence. Then you add on more supplier domain. So eventually it's changed the way how we define from the product-driven or manufacturing-driven world to a service-driven economy. So I call the fried egg model. The York area is the product, and your egg white area is the value create for services. So that is a new generation of economy. Yeah.
Well, speaking of eggs, the meal is over, and
Yeah,
I want to
perfect
thank our panelists for a really wonderful conversation.
Thank you.
Thank you.